Let's read a story for today about a fast food who is offering a free French fries and drinks. And that's a wow, right? We all want free foods. Now, the story is about a fast food owner offers a free drink for every 15th customer and a free French fries for every 20th customer. When can a customer get both a free drink and free fries at the same time? So, in order to solve this kind of problem, we need to use LCM. So, what is LCM? LCM, or the least common multiple of two or more numbers, is the smallest number that is a multiple of all the given numbers. Now, how do we find the LCM using the continuous division method? So there are steps that we are going to follow. First, divide the numbers using a prime divisor until you get the prime quotient. So again, when you say prime numbers, these are whole numbers greater than 1 that have only two factors, 1 and the number itself, such as 1 times 2, which is 2, and then 3, 5, 7, 11, and so on. Next, multiply all the prime divisors and the last quotient to get the LCM. So the process of continuous division method is like getting the GCF. But for the step 2, you need to multiply the prime divisors and the last quotient to get the LCM. Because if it's GCF, you just get the prime divisors. You just need to multiply the prime divisors. Now let us answer with the problem. When can a customer get both free French fries and free drinks at the same time? So using LCM, what you're going to do again to follow the step, divide the numbers using the prime divisors until we get the quotient. So we have 15 and 20. Then use the continuous division method symbol and use prime numbers that is divisible by both 15 and 20. We have 5. 15 divided by 5 is 3. 20 divided by 5 is 4. So there is no common factor between 3 and 4. So you end there. And to find for the LCM, the step 2 is to multiply the prime divisors and also the last quotient. So when you multiply like this one. So you multiply 5 times 3 times 4. So 5 times 3 is 15 times 4 is it's 60. So on the every 60th customer, you can get free French fries and free drinks at the same time. So the LCM is 60. Okay, so let's have another example. So let's find the LCM of 12 and 16. So again, first step is you divide these two numbers by its prime divisor or prime numbers, and both divisible by these two numbers. So for 12 and 16, we have 2. 12 divided 2 is 6, and 16 divided 2 is 8. Another common factor is still 2, so 6 divided 2 is 3, and 8 divided 2 is 4. So there is no common factor between 3 and 4, so you multiply the prime divisors including the last quotient. So when you multiply it, it's like you multiply it like letter L to find for the LCM. So you multiply 2 times 2 times 3 times 4. We will get, so 2 times 2, 4 times 3, 12 times 4, 48. Therefore, the LCM of 12 and 16 is 48. Next, find the LCM of 8 and 12, to 8 and 32. So we have 8 and 32 divided with its prime divisor, which is divisible by both 8 and 32. We have 2, we have 4, and this one is 16. Another common factor is still 2, so we have 2 and this is 8. Another common factor, which is 2. 2 divided 2 is 1, 8 divided 2 is 4. No more common factors, so you multiply this one like letter L. So 2 times 2 times 2 times 1 times 4. Let's multiply. 2 times 2 is 4, times 2, 8, times 1, 8, times 4, it's 32. Therefore, the LCM, or the least common multiple of 8 and 32, is 32. Next example, find the LCM of 14, 15, and 20. If you're going to find the LCM of three numbers, check if there's any numbers that goes into any pair of remaining numbers. Notice that if there's a number that doesn't go into, leave that number as is. For example, we have 14, 15, and 20. The common prime number of these numbers, if you're going to use 2, it cannot be because it's not divisible by 15. If you're going to use 3, it's not divisible by 14 and also 20. If you're going to use 5, it's not also divisible by 14. So for LCM, as long as two numbers have the common prime numbers, you can use that. So we can use 2 for 14 and 20. So let's put 2. 14 divided by 2 is 7. And since 15 is not divisible by 2, then you just write 15. Leave it as it is. For 20 divided 2, it's 10. So in these three numbers, 7, 15, and 10, there is no common factor between these three. So we can just, at least two numbers that is divisible by 15 and 10, we can have 5. So you can still continue. Unlike the GCF that you need to have all of these numbers to have a common prime numbers. So 7 divided 5 cannot be, so you just write 7. 15 divided 5 is 3. 10 divided 5 is 2. So there's no common for 7, 3, and 2 anymore. So you can end there and you multiply the prime divisors and the last quotient. So the factors are 2, 5, 7, 3, and 2. So you multiply that. 7 times 2 times 5 is 10, times 7 is 70, times 3, it's 210, and times 2 is 420. So the LCM of 14, 15, and 20 is 420. Last example. So find the LCM of 4, 12, and 16. So find the common factor of at least two numbers. We have 2, so 4 divided by 2 is 2, 12 divided by 2 is 6, 16 divided by 2 is 8. There's still common factor between these three, which is 2, 2 divided by 2 is 1, 6 divided by 2 is 3, 8 divided by 2 is 4. So there's no common between 1, 3, and 4, so you can now multiply the prime divisors and the last quotient. So we have 2 times 2 times 1 times 3 times 4. So that is 4 times 1, 4, times 3, 12, times 4, it's 48. So the LCM of 4, 12, and 16 is 48. So again, to find the LCM of two or more numbers, first you need to divide the numbers to its prime divisors and then multiply all the prime divisors and the last quotient to get the LCM. Now, the story earlier is an example of how LCM is used in real life. Another example is for a Christmas light. Using LCM, we will know the time when all the small bulb will light or glow at the same time, and a lot more. LCM also is important when adding fractions which have different denominators, which we will discuss next week.